Okay, welcome to video 5. Here we're going to be talking about using regressions with sequences. So remember that regressions are something that we have done already. Now we're just going to use them with sequences instead of functions. So since sequences are terms in a list, these terms can represent points in a table. If we have points, we are able to use the regression command in our calculator to create equations for functions, such as linear and exponential functions. So recall that arithmetic sequences follow the pattern of a linear function, and the geometric sequences follow the pattern of an exponential function. And those make sense because remember, arithmetic sequences have a common difference, and so do our linear functions. And geometric sequences and exponential functions both have a common ratio. So regressions are an equation of a function, linear, exponential, etc., that the plotted points follow or create. Our correlation coefficient, the R number, this number describes the strength of the equation in regards to the plotted points. And remember that your diagnostics must be on in order to see that R number, which will tell us if it seems like a good fit or not. And a perfect fit equation will have a R value equal to -1 or -1. Remember, that just tells us if it's positive or negative relationship. But if it says 1 or -1, we at least know that it goes through the points that we've put in our calculator. Now, as far as a linear function, if we have 3 points, that is more helpful than 2, because if we have 2 points, no matter what, the R value is going to say that it's perfect because only one line goes through 2 points. Okay, so let's move on to the next part. So how to use a calculator to create linear and exponential equations. What's needed for linear equations? Well, remember we just talked about needing 2 exact points from a table or graph or word problem because we know there's only one equation that'll go through 2 points. But if we have more, that's always helpful. Exponential equations, we want 3 exact points from the table, graph, or word problem. And that's because of the curve aspect. We want to make sure that we have the right equation. And we can put points in a list, so by pressing Stat, Edit, and then we edit our list. Remember, we can clear the list by going up, clear down, if there's already something in L1 or L2. So then we put our X values in L1 and our Y values in L2. Then you can choose either lin-reg for a linear or xbreg for an exponential. And that's by going back to stat again and moving over on the top to calc. So you have to hit the right arrow to move over to the calc tab. And then you can select either lin-reg or xbreg from the list. Then we want to try to verify it's a perfect fit equation by looking at the R value. It must be positive or -1 to be perfect. But again, remember that this will really help us when we have more than 2 points in there. That'll tell us that it seems like we picked some good points because it goes through all of them. Then we write the equation stated by filling in the appropriate values for the coefficients, just like we've done already. And the last part is to explain in words the steps you did to get the equation, since there was no math involved in writing the equations. Okay, so none of that information was new. So what do you do differently with sequences? Well, we still need to identify the pattern of the sequence through the diagrams or a description, so decide if it's a common difference or common ratio. So if you have enough information to use the arithmetic or geometric sequence formulas from the reference table, then we should use those, the reference sheet that you're given on the exam. But if you're missing key information, we can list terms of the sequence as coordinates and use a regression to make your equation. So example 1 says we have an arithmetic sequence, and we know a sub 4 is 9 and a sub 8 is -15. So the 4th term is 9, the 8th term is -15. Well, I don't know the common difference because these are too far away. I can't say how much I've added. And I don't have the first term, a sub 1. So I think I'm missing 2 key pieces of information for this. So I'm going to want to do a linear regression here. So I'm going to start off by listing my sequence information. So I knew that 4 was with 9. The input of 4 had a y value of 9 and 8 with -15. So now we can do a linear regression in your calculator. So follow the steps above to give this a try following what we've done in the past, and we'll go over this in class. Have a good night.